doing example 5, section 7.2. So we're, again, trying to find an antiderivative using substitution. So as with the other ones, we sort of want to decide what is u going to be. And the general way to think of that is usually u is going to be what's in the denominator, what's under a radical. In this case, it's what's up in the exponent. So we're going to say u is equal to x squared. And then, as we always do, we take the derivative of that du, in this case is 2x dx. Okay? So now I just notice over here what I've got is x dx. I've taken care of this part of it, the e to the power of x. I still got an x dx, though. Here's the x dx that's going to take care of that. I've got an extra 2 there. I don't need it, so I'm going to just divide both sides by 2 and get 1/2 du is equal to x dx. Okay, so now if we come over here and just look at what we've got, the x and the dx together, and we're just going to circle that, the x and the dx together, what does that become? What does that become? X dx becomes 1/2 du. Okay, so that's 1/2 du. The rest of it, the e to the power of x squared, what does that become? Well, according to our substitution, u was x squared, so that becomes e to the power of u. Okay? Make sure this is fitting on there. E to the power of u. Okay, so with that, we can rewrite our integral in terms of u now. Oops, let me use the right color pen here. What happens to this thing? It turns into, well, we just said that that part is e to the u, okay? And the rest of it, x dx, becomes 1/2 du. So I'm going to put the 1/2 in front since it's a constant, and then the du goes here. Okay? So this is telling me that I have an integral now in terms of u. What is the antiderivative of e to the power of u? It's just itself. That's that really nice function. That is its own derivative and its own antiderivative. So we're going to get e to the u plus a constant. And then the last step is to just replace that with what u was, so 1/2 e to the power of what was u? It was x squared, and then plus a constant here. Okay?